Hi everyone, today we are going to discuss trie data structure. So first point is what is the trie data structure? So we can say that trie data structure is a tree that stores the strings. The maximum number of children of node is equal to the size of the alphabet. So as we know the 26 alphabet in English, it means one node having the 26 child and try support the searching, insertion and deletion operation in big O of L times, where L is the length of the key. We can say that length of the string too. So next point is why we use string. Yes, it is most important questions. There are lots of data structure, binary, linked list, hashings. So why we use the trie data structure? So as we know, every data structure have a own property. So tree is having a own property. So one of the first property is that in trie we can insert and find a string in big O of L times, where L represents the length of the single word. This is obviously faster than binary search tree. This is also faster than the hashing because of the way it is implemented, and we do not need to compute any hash functions. No collision handling is required. So this is the biggest use of trie. And the second most important is advantage of trie data structure is we can easily print all the words in alphabet order, which is not easily possible in hashing, because in hashing we store the words in a key, but in data structure we store the word with the help of its own characters. So we can easily print the words. And next and third most important advantage of trie, we can efficiently do prefix search or auto completed with the trie. So this is the most advantage of trie. So if there is advantage, so obviously there is a disadvantage too. So what is the issue with the trie, or we can say the disadvantage of trie? So first disadvantage is that they need a lots of memory for storing the string. For example, node have too many nodes pointer equal to the number of character alphabet, which I already explained. If one node having a 26 children's child, so it's always take lots of memory. So this is the biggest disadvantage of trie data structure. So let's understand with an example with the trie data structure implementations. So basically, let's take an example. We have an array with four words, the, their, answer and any, and we need to create a trie through which we can insert a word as well as search the word, or we can check this word present in trie or not. For example, we are insert four word in trie: the, their, answer and any. So we are giving some word, so we can check this word is present in trie or not. So we can say that the is present in the array, yes, so we can present in array tree. Next is there. So as we can see, there is not present in the input array, so we can say that not present in tray. But after that, third example is there, we can say the second word of the array is there, so we can say present these there word is present in try. And thou, we can see here there is thou not present in array, so we can directly print the not present in try. All these uh, word insertions and searching, we can solve this issue using the try. So before jump to the code section, so understand the how to implement the tree try tree. So let's understand the try. So as we can see here, let me zoom out. Okay. So this is the implementation of try. In a try, firstly we have to create a root. So one root having a 26 alphabet children. So if we need a, we can convert that null. Every all childrens are inslide with null. If we need a alphabet child, so we can inslide the undo the null and replace the null value with the character which is present in word. For example, we have a first word is in array is the. So we can check root having mm, t is present associate with the root. So we can say no. This is a starting point, so there is a no character associate with the root. So firstly, we have to create a new node which are sliced with which and put the t character in the uh, in the structure, in the trie structure, and associate with the root. So next insert the h. So as we can see here, t is already associated with the root. So let's insert h. So when we insert h, we let's go into the root. So we can check t is already present. So t is just after the h. Just h is just associate with the after the t. So we can associate the h with the t, and we can also have a one boolean data type. We can check this is the end of the word or not. So let's see for the for the first character is t, so we know the ending word ending with e, so we can uh, we cannot change the h with the let me so let's for example we adding h with the root. So as we know, h is not a word ending of the, so we can make it a word ending as a false. And next character of the is last character, which is e. So now we can add we can create a node and attach with the h. So as we can know, e is the last ending character of the, so we can change the we boolean data structure with a true, because this is the ending of the. And now next one is there. So as we can see here, when we start adding these word in root, so we can start with the t. So as we can see, t is already associated with the t, so no need to add a t again. So check the next character, which is h. So let's check the h is also associated with the t, so no need to insert a new node. Next, third one is e. So as we know here, e is already associated with h, so no need to add a new node with h. So after that we can see R. R is the new character which is not associated with the E. So now we have to create new node and associate with the E. So as we can see here, R is created which word ending is false and associate with the E. And third and fourth character, which is E, which is not present, not associate with R, we need to create a new node and associate with the R. As we know, their E in their word is ending, so we can change the we uh, to the true, which means this word is ending at that point. And third word is answer. So in answer, first character is a. As we can see here, there is no character associate no a character associate with the root. Now we have to create a new a character node and associate with the root. So now I'm creating a, now we can see here a is created and associate with the root. So as we can know, as we know, the W is the A is not ending character of the word, so we can we do not make changes with the WE boolean data structure, and which is as it is false. And next is answer A N data structure A character. So as we can see here, A is not linked with any character, and so now we have to create a new node and associate with a, and don't take change the we as a make it as a false, because n is not the ending part of the answer root. So similarly for s, similarly for w, it's similarly for e, similarly for r. For when we implementing attaching check insert a r in the root, so as we can know, r is the last character of answer, so we can create a node, new node, and associate with E, and make a WE Boolean data structure, make it true, because this is the last character of answer word, and the last word, which is any. It's so we have to add any word in also the try. So first character of the any is a. So as we know, root is also as already associated with a. No need to create a character with root. So now check the next one, which is n. So we can see here uh, a, and after that a, n is already associated for the answer word, so no need insert a new character of n with associating with a. So we need to jump to the next word, next character, which is y. So as we can see here, when we jump to the a is already present, n is already present. When we insert a y, there is no nodes present or associate with the n. So we need to create a new node and associate with the n. So we can see here I already created a y node and associated with n. And the most important, we need to uh, change the WE data structure booleans to the true, because for any y is the last character for the any words. So this is the how we can implement the trie data structure. So let's jump to the coding section. So where we can exactly know how to implement the trie data structure, because this is the basic starting point of the trie data structure. So let's jump to the implementation part of data structure, trie data structure. So as we know, we can create a trie data structure in a class and data structure with the help of class and structure. So now I'm going to use C++. So now I'm implementing these data structure using a class. So uh, you can also create a trie data structure using a structure, but in the C condition we cannot use, because there is a in in C language oops concepts are not present. So we can, if you are using a C language for competitive programming, so you cannot use a class on C. So but today's we are going to implement this data structure in C++. So now I'm going to use as a class for uh, implementing the trie data structure. So firstly we need to create a class which we can call it trie node, and make it all data type and constructor publicly. We don't give me 2 minutes. I will back. So first we have to create a char data type which is stored the character of word data, and next is a trie node. So if we create a node, if we create a any node, so we can also create a 26 children for it, which I already explained when I explaining the data structure, trie data structure with the tip on the 3 points, like uh, what is trie data structures, and second is the why, and third is the issue. So now I'm giving this data type as children, children 26. So as we know 26 alphabet in English, so we are going to create a 26 children for a particular node. So next is boolean, so which I already explained, word ending. So now I'm going to is terminal, I'm giving naming it word end, word end is equal to not equal to okay. So these these bool data type is used to display, used to check the this is the last character of the word or not. So we can use this word and data type. So now if we create a so after that we need to create a constructor which is in slice this all this data type. For example, we need to create a trie node. So when we create a when we call this class, so we can pass the character which we need to create a node. So we can pass with the help of constructor and store in the data. And next we need to slice the all 26 uh, children with a null. So now I'm going to create a for loop and I is equal to I smaller than 26 plus plus children I is equal to null. And most important, if the when we create a node, so it is not clear it is the last ending word of the ending character of the word, so we need to slice with false first. Word end is equal to false. So this is how we can create a try node class. So now create a try class where we can create a functions and as well as perform an operation in it. Give me 2 minutes again, sorry for that. Let's create a try class. In try class we make sure all the functions and all the functions in the try functions is public because we are going to use outside this class. Firstly we need to create a try node. We can call it as root. At the same time we are calling the constructor which create a root which is in slice with null. Try node. So this slice is null. So now I'm going to create a first function which is insert function. So we can call is void insert word string. So with the help of this function we can call the another function which name is insert util. We can call insert util. So we can pass in the function we can pass our root which we are creating where we call this function comma pass the word string in it. I'm going to create insert util function void insert util function. So first is try node star root comma string word. If word dot length is equal to 0, it's mean if we reach the last character of word, so directly change the word end with word end as true, is showing this is the last character of the word and we can directly return. Basically this is the base case of the this function. We can use a recursion in it, it is most important. So after that we can, so if the it is not the last word last character of the word, now we have to create a index which is stored the character minus a minus a. So as we know here, I'm creating a 26 childrens of any row. So if we create another node, if we create a node for that children, so we need to check which is the index of the that character. So we can use this for so as we know, if we have a b character. So in B character, as we can know, B sky value of B, sky value of small a is 97 and 98 for B. 98, okay. So is 98 and another sky value of A is 97. It's mean when we minus this 98 minus 97, we get 1. So we can know children of 1 is equal to store the alphabet B, and this is the how we can use the index word to check to add a character in the trie. So now I'm to create a trie node child data node again, which we can use to slice the new node in the trie. So if root children index. So firstly we check the index is already present in it or not. So if the character is already present, so we can simply store the in the child trie node store the child trie node that node which is already present in the nodes children's part, children index, and else if no such character present in a node, so we need to create a new node. So for creating a new node, so firstly we need to create a new node, new try node, and passing the character word 0 and slice and slice word ending as a false. No need to which is already that sorry that is all automatically in slice when this constructor is called. So we need to call the children index. We need to initialize child is children index equal to child. So for example, if we insert let's say if we want to insert w with the s, so we need to create a s which we are create and store in the child, and now we are going to add this w child with the s. So we need to add root children index child, which is associate w with the s, and this is the use of this line. So after that we can call our insert function again to check the next word, to jump to the next character. Insert little child comma word dot sub str comma 1. You can directly google it what is the use of substring, So you will know the use of the substring function, because these substring, for example, we have a word a and y. So if we just a second, if we have a word a and y, so if we use this function, if we use this function, it's a return n. So we need to, so if we word there, so t is already implemented, we need to implement h, so we can use this substring function here. And this is the implementation of insert function of any word in a trie. Let's create another function. We just a second, we need to delete this first. So after that we need to create a search function. For search function, no need to create a, so this is a search function having the same code. So what first we need to create only function name here, search search word. So we can pass in these function word. So now we going to call our character function, return return search, in which we pass root as well as word. So we need to create a new one. Let's use the same code again. So firstly we need to change this void to bool, because we return if the word is present, is the word present in a trie, so we print just return true. If not present, just return the false. So make a series changes with this function, so we can use, so we can change our search function accordingly. We, so if the length of the word is 0, let's check uh, word and return word end. If the word end is true, it's mean, and this is the last character of the word which is present, so we can directly return word function here. So no need to insert. So if the word is not present, we can directly return 4. So this is search button, so we also try it. So if we pass THEIR, so we know there is all, their word is not present in there in the AR function. So if we go T, so if we search the T, so we can see here T is present. Now let's jump to the H, check for H. So as we can see here, H is already present. Now check for E. So as we know, THE is already present, but we can check I. So we know that I is not associated with E. It means E, their word is not present in try. So we can directly print not present in try. If we check the, so as we can see, first character is T. So we can see T is present. So if check for H, we can see H is present. So we can check E. So we can see E is present and the word end is true. So it's mean THE is present in a tree. So we can directly return present in try. Sorry, sometime I call try is tree. So please ignore it and understand like tree. Sorry, try again. Try. Okay, and this is the how the search function work. So let's create some, pass some input here. Let's create a new try, star tree, new tree, tree. dot call, we can call this insert function, insert word, and pass word. So let's check any error or not. So first children was not declared in the scope child. In the 39, 38 and 39 child is equal to, okay, insert util, oh, root, run it again. So again 66 line have the same mistake. Run it again. What is wrong with an EW try? Getting try. So new add equal sign between them. So no error at all. So let's check. Let's check search function. Present or not. Dot search function. We can call our search function here and pass a string A, B, C, D. 74. Warning control reach and node void at 74. Search vital. Let me check search util root node, and this is correct word, and that is correct, and root and false, which is correct. Why it's giving a warning? 74 and 3 today correct. I don't know what's wrong. Search util child and word, okay. Child is present, word is present, things looking. So let's run it again. So now it's working. So as we can see here, we put a word inside the tree but searching ABCD, which returns 0. It means there is no word ABC present in a try. So let's change this ABC with word. So when we run this, so it's still giving the same. Let me check it again. So let's replace again, check AB with ABCD. So it's showing 0, but when we pass the same word in search function and run it, so as we can see here, now it's printing word. It means word is present in the try, which is inserted using the insert word. And this is how try data structure work in DSA. So in the next video, I will going to explain new code which is related to try. So word break problem. So in the next video I will explain the word break problem. Close it. So now thank you for watching this video.